Every real number is the zeros of a zero polynomial is A true, B false, C can't say, D partially true. Degree of a zero polynomial is not defined, but zeros of a zero polynomial is any real number. So every real number is a zeros of a zero polynomial, hence answer is true. A1, B2, C3, D more than 3. The equation of a quadratic polynomial is x square minus sum of the zeros times x plus product of the zeros. So here sum of the zeros are minus 2 plus 5, which is 3, and the product of the zeros as minus 2 into 5, that is minus 10. So we get the equation as x square minus 3x minus 10. We know that the zeros do not change if the polynomial is divided or multiplied by a constant. As k can take any real value, there can be many polynomials having minus 2 and 5 as zeros. So therefore D is the correct option. If alpha and beta are the zeros of the quadratic polynomial x square minus 6x plus a, then the value of a if 3 alpha plus 2 beta equals 20 is minus 12 is A true, B false, C can't say, D partially true or false. Now first thing that we can do is to obtain the sum of the zeros, which is minus b by a. So minus of minus 6 is 6. And the product of the zeros, that is alpha into beta, which is equal to c by a. C is a here, so a divided by 1 is a. Now we are given here 3 alpha plus 2 times beta equals 20. So what we can do is to split 3 alpha as alpha plus 2 alpha. So alpha plus 2 times alpha plus 2 beta equals 20. So this is alpha, and if I take 2 common from here, this is alpha plus beta equals 20. So alpha plus 2 times alpha plus beta, and alpha plus beta is 6. So we can replace this with 6. That results to give the value of alpha as how much? 20 minus 12, which is how much? 8. So we got the value of alpha as 8 here. Now we know the value of alpha plus beta, so substituting alpha as 8, we can get beta from here, and beta comes out to be, it is coming as 6 minus 8, which is negative 2. Now once we got the value of alpha and beta, we can obtain the product of the zeros, which is a here. So product of the zeros is what? The product of 8 into 2. So replacing alpha beta with the product of these two, which is how much? 8 into 2, which is 8 multiplied by, this is 8 multiplied by negative 2 as the product of the zeros, right? This is alpha beta. And as for the question, as for this information, we have alpha beta as a, so we can replace this with a, and this comes out to be minus 16. The zeros alpha and beta of a polynomial x square minus 7x plus k are such that alpha minus beta equals 1, then the value of k is a 21, b 12, c 9, d 8. We know that sum of the zeros of a polynomial is what? Minus b by a. So it's minus of minus 7, that is 7 over 1. And we are given alpha minus beta is given as 1. Now eliminating beta over here, we get what? 2 times alpha equals 8. That results to give alpha as how much? 8 divided by 2, that is 4. Now from here we can now obtain beta, replacing alpha as 4. So this is 4 plus beta equals 7. So we get beta as how much? 3. So once we get the value of alpha and beta, we'll be using the product of the zeros to obtain the value of k. And what is product of the zeros? It is c over a, c which is k here. So k over 1 is k only, and product of the zeros are nothing but the product of these two, that is 4 into 3, which is 12. So we can say that the value of k is how much? 12.